Hello students, your teacher John Brazil again, and today we have a question with Kirchhoff law and simultaneous equation. Now, a lot of students struggle to get this question right, so I'm making it available here on video so you can pause and you can go back and watch it again if you struggle. Now, we have two voltage source. This is the DC voltage source, and we have a circuit where we have, this can be turned into one resistor, okay? They're doing series, just add them together. So that's equivalent to a 12 volt resistor. Now we have three resistors when one is in parallel. So what we're gonna do now, we're gonna split this circuit into two circuits, the left hand side and the right hand side. Now we're gonna analyze it. By Ohm's law, we know that voltage equals current times resistance. So these resistors times current I1 will equals the voltage. So we're gonna analyze this and we're gonna say that 12 volts equals 10 plus 2, 18I1 plus 6I1 plus 6I2, which is the interference of I2 in this specific resistor. As we do the summation of 10 plus 2 plus 6, so you got 18I1 plus 6I2. This is our first equation. Now we're going to build a second equation, starting from the second voltage source, which is 9. Now you're going to have I2 with interference of 22 plus 6, which is going to be 28I2, plus 6 of I1. And here it is again. 9 volts equals 28 I2 plus 6 I1. What I like to do when I make it easier, you rearrange it and you put both equations next to each other, where you have I1 in the first term and I2 in the second term. By looking at these two terms now, you know how you can eliminate one of the unknown variables. Let's call it x and y. So you're looking at 18 and 6 and 28. It's easier for you to make 6 and 18 LMC, the lowest minimum common. You do that by timing 6 by 3 and it becomes 18. However, don't forget you need to times the whole equation to keep it a state of balance. So times it by 3, you're going to get 27, which is 3 times 9, 18, which is 3 times 6, and 84, which is 28 times 3. Now you repeat the first equation underneath it, because what you're going to do for simultaneous equation, you're going to subtract the first by the second. So 27 minus 12 equals 15, 18 minus 18 equals 0 I1, plus 84 minus 6, which is 78 I2. Once you've done that, now it's just a simple case of substitution, and then you can find the value of I2. So you have I2 equals to 15 divided by 78, which gives you 0.19 amps. With the result of I2, you can go back into your first formula and substitute it there. So it's going to be 6 times 0.19 equals 18y. So you're going to go I1 equals 12 minus the value of 6 times 0.19, which is here shown in the formula, is 10.85. And then all you have to do is just divide it 10.85 by the 18, which was timing the I, and you get a result of 0.61 amps. You can have a look at the formula, pause and write it down. And finally, to find I3, all you have to do is to add I1 plus I2, and then you get the final value of 0.8 amps, or 800 milliamps. Now, one thing that you need to notice, if any of these values were minus, then you would understand that all it is that the direction that we chosen to analyze the circuit was wrong. There's no such thing as a minus current, it's always going to be positive. So you just correct that and say, okay, the direction of current is going that way instead. It could be that this power source was powering both this resistor and charging this other power source. Okay, students, thank you for your attention. Don't forget to share, like, and subscribe, and press that bell button.